Yo, 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 what's up, everybody? This is the professor, and I'm here to talk to you today about three things that you need to remember about the blood. Most of the time, people have at least a chapter about the blood in anatomy and physiology, and it's like, yo, there's so much random information about the blood. And believe it or not, if you remember these three topics concerning the blood, then you'll be able to pretty much funnel everything else under these things. So the first thing I want to talk to you about with the blood is you got to remember that the blood is actually a tissue. And the type of tissue that it happens to be is liquid connective tissue. Now, understand this: a tissue is a group of cells that are working together towards a common goal. So a tissue is like a team, and every team member is a cell. And they can be different types of cells, but it's just that collectively together they work as a team to make something special happen. Keep that in mind. That's why blood is a tissue, but specifically it's a liquid connective tissue. Now, I don't know if your instructor told you this, but with a connective tissue, there are three things that make a connective tissue a connective tissue. Number one, it has a matrix. Number two, it has specialized cells. Number three, it has protein fibers. If those three things exist, then it is considered a connective tissue. Now, here's the funny thing about it. The way that you can remember connective tissue or a liquid connective tissue is think of a bowl of cereal. So I don't know what cereal you eat, whether it be Fruity Pebbles, Frosty Lucky Charms, Kellogg's, Corn Flakes, Frosted Flakes, I don't know, whatever your cereal is. Imagine that the matrix is the milk, and the specialized cells are going to be the cereal. And then if you're eating Fruity Pebbles, then the protein fibers are going to be the special addition items that are in your cereal. And that's what connective tissue would be, and specifically liquid connective tissue. It's got to have a matrix, which is whatever the cells are suspended in, and specialized cells, which is just a fancy way of saying these are cells that focus on doing a job rather than replicating all the time. And protein fibers, which is some type of protein that can be used in some type of special way. And in this case, when you're talking about blood as a tissue, these protein fibers are going to be fibrinogen, which converts into fibrin, which causes a blood clot. The specialized cells are red blood cells and white blood cells, and the matrix is blood plasma. So that's the first thing that you need to remember. Man, that was a mouthful. That's like a whole lecture in like 2 minutes. But the second thing you need to remember about blood is that blood is a solution. Now, when you say that you're talking about a solution, I used to get confused about this in my classes because my professors would say, oh, it's a solution of blah, blah, blah. I'm like, what the heck is a solution? So if you're going to think about a solution, think about Kool-Aid. All right. Kool-Aid is a solution. Seriously. You've got water, you've got Kool-Aid powder, and you've got sugar. A solution is made up of two things. Here we go. A solution is made up of a solvent and solutes. So basically, I've got a solvent which can dissolve solutes, or you can think of it in a different way. You can say that solutes are things that dissolve in a solvent. So as far as Kool-Aid is concerned, my solutes are going to be sugar and my Kool-Aid powder. And then my solvent is going to be water. And when I mix all of that stuff together, the sugar and Kool-Aid powder dissolve in the water, and then I get a solution. That's what you're talking about. That's all a solution is. When someone tells me, oh, we're reading something about a solution, that tells me, oh, it's some kind of liquid with stuff dissolved in it. Cool. All right. I can keep that in mind. Blood is a solution. So you got lots of things in there. You've got water, which is going to be my solvent. So you got water, and then you got solutes. Now, what kind of solutes do you have? Man, there's a lot of things in there. So you've got glucose, you've got glucose, you've got amino acids, you've got all types of minerals and vitamins. you've got all types of things that are dissolved in the water of your blood. And then you have cells that are floating around in there. Now, the cells are not dissolved in the water, but they are in there. And then you have other items, which as you go through anatomy and physiology, you learn that these other items are things like hormones and waste products like lactic acid and uric acid and all these other things floating around in your blood at any given moment in time, and it's all mixed together at one time. And that's why we refer to blood as a solution, because it's water with a whole bunch of junk mixed in. The third and last thing you need to remember about blood is that blood is a fluid. So because it's a fluid, it functions like it. So if you've never taken physics before, or you've never really actually paid attention to how a fluid functions in a pipe, then you might want to pay attention to that now. It's not very difficult. You got technology. You can go to YouTube and you can watch a quick 2-minute video on how pressure is created in a pipe simply because there's a fluid that's moving through it. This is important to remember about blood, because as blood moves through your blood vessels, it is pushed through your blood vessels using pressure. Where does that pressure come from? That pressure is created by your heart. So every time your heart contracts and it pushes blood out of the ventricles through the semilunar valves and into either the aorta or your pulmonary trunk, as pressure is coming out of your heart, it pushes the blood out of your heart and it pushes it throughout your blood vessels. But this is key, because that pressure doesn't just go out and then disappear. That pressure travels with the blood, and as blood is moving, it creates its own pressure because, well, it's a moving substance. So there's a pressure that is created simply because blood is moving. And then, of course, blood is made up of water. Probably around 50 to 55% of your blood is nothing more than water, and water holds heat very well. Therefore, blood circulating through your body circulates heat because of what I just said. Your blood is made up of water, about 50 to 55%. So that water then holds the heat, and as it travels through your body, it circulates that heat, and that's what keeps you warm. I mean, you got to think about this, the fact that your body is normal body temperature is 98.6 degrees Fahrenheit. Now, if you were outside and it was 98.6 degrees Fahrenheit, you'd be yelling about, hey, I need to go inside and get some air conditioning. But your body is happy at 98.6 degrees Fahrenheit. And a part of that is because of the heat that is being circulated by your blood. And these are the 3 areas that you want to definitely remember when you're learning about the blood. And you can put everything else, you can hang your hat on these 3 areas for just about everything else. So make sure you hit that like button. Make sure you subscribe to the channel, and we'll look forward to talking to you next time. Peace.